Hello! Today we're going to talk about measures of dispersion, or in other words, ways to describe spread. So we've got this set of data here, 1, 4, 5, 5, 5, and 10, and we're going to learn a couple of ways to describe how that data is spread out. So the first one that we're going to talk about, I'm pretty sure you've seen this before, that's the range. And you'll probably remember that the range is taking your highest value of your data set and subtracting the lowest value of your data set. What this does is it shows us the distance covered by the data. Okay? So it just gives us that distance covered by the data, how far the data is spread out from the largest to the smallest. The next one is the interquartile range. You might have seen this one before. You probably have in Algebra 2. The interquartile range is quartile 3 minus quartile 1. And what that does is that's going to show us the distance covered by the middle half of the data. So remember, the quartiles are going to come from the middle or the median of the lower half and the upper half of the data. So you find the median of the data, and then the lower half's median and the upper half's median, and that's going to be your quartile 3 and your quartile 1. This is more often called the IQR. So our last one is the standard deviation. And the way we calculate standard deviation, well, first of all, we're going to call it sigma, the lowercase Greek letter sigma. That's going to stand for the standard deviation of a population. Not a sample, but of a population. We'll talk about that in a little bit. What it is, it's going to be the square root of this large fraction, where in the numerator, we're going to take our first data value, x sub 1, and we're going to subtract from that the mean. Then we're going to square that value. So we're going to have to calculate the mean as well first. Then we're going to add that to the next data value, x sub 2 minus the mean, and we're going to square that value. We're going to add that to the next one, and the next one, and the next one, all the way until we get to adding it to the last data value, x sub n, out of n values, minus the mean, which we will then square like all the rest. All of this will be divided by n, the number of numbers, and then we square root the whole thing. What this is going to do, this is going to show us the average distance from the mean. So if you look at this equation here, it really does look like, let me get my pen out here so you can see what I'm doing. But if you look at this equation, if we're adding up all these values and dividing by the number of numbers, we're finding an average. That's your average. But what is that an average of? Well, if you kind of ignore the n for a moment and just look at the square root of all these, that looks a lot like, right, the distance formula. So this is kind of a combination of distance and average. It's the average distance, right? Average distance from the mean. So what we can also do here, let me go ahead and change colors here, we can write this in a different way. We can say that sigma is, we're going to use summation to do this. So we're still going to need a square root. And now we're going to do 1 divided by n. There's your divide by n portion right there. And we're going to do that of the summation of I going from 1 to n, the number of numbers. And what you're going to do is you're going to take x sub I, or the ith number, so your first number, your second number, your third number, fourth, all the way to the nth number. That's this guy right here. And we're going to subtract the mean and square it. And this is the same as this. I think they show you this in your textbook. This is it written out a little bit more directly. So let's do some examples now with our data set we have up here. So we have a high value of 10. We have a low value of 1. So we can find the range of that by simply doing 10 minus 1. And we get a range that equals 9. We can find the interquartile range, but first we have to find that Q3 and Q1, and to do that we need the median of our data, which is going to be right here. I'll put an M there between those two 5s, and we would add them up, divide by 2, and we'd find that the median is 5, but it's not that 5 and it's not that 5, it's the number between them. So this 5 still belongs to this group here, the lower half of our data. This 5 still belongs to this group here, the upper half of our data. So the median here, you can pretty easily see, there's your quartile 1. The median up here, there's your quartile 3. So down here, we can solve for an IQR of 5 minus 4, Q3 minus Q1, 5 minus 4. And that gives us 1. So our IQR, there's your IQR, our IQR equals 1. So the middle half of your data has a range of only 1. All of your data has a range of 9. So that kind of implies that our data is all kind of towards the middle. Now the last one we're going to do is that standard deviation. So we're going to go ahead and say sigma equals the square root, we've got a bunch of these to do, of the fraction, and we're going to take our first data value, 1, minus the mean of 5 squared, plus 4, the next data value, minus the mean squared, plus the next data value, 5 minus the mean squared, the next data value, 5 minus the mean squared, plus the next one, 5 minus the mean squared. One more, we've got to extend that out. One more plus 10 minus the mean squared. Extend our fraction bar, and all this is going to be divided by 6. Yes, there are 6 data values in our set. So, as we keep simplifying this, we get the square root of all of this over 6. 1 minus 5 is negative 4 squared, plus 4 minus 5 is negative 1 squared, plus 5 minus 5 is 0 squared, 5 minus 5 is 0 squared, 5 minus 5 is 0 squared, plus 10 minus 5 is 5 squared. So we keep simplifying this, and what we end up getting to now is that negative 4 squared, negative 4 squared is 16, negative 1 squared is 1, 0 squared is 0, 0, 0, and 5 squared is 25. All divided by 6. So we add all that up, and we end up with the square root of 42 over 6, which equals the square root of 7, which we're going to get an approximate answer right about now when I go to the calculator and we do the square root of 7 is approximately, it's 2.6457513110645, blah, blah, blah. So let's just round it to 2.65, approximately 2.65. Let's make that look more like a 2. And there's our standard deviation, the average distance from the mean. So if we go back up here and look here, our mean was 5. We found that earlier. Actually, I guess we never did find it. We needed to find that mean. I knew it already, I'm sorry. But if we add the 1, 4, 5, 5, 5, and 10, let's put that over here to the side, we would find that x bar equals 30 divided by 6, which is 5. So we did need to know that one. I'm sorry, I just skipped on past that. But so if the mean is 5 and the median is 5, that average distance, think about that, the average distance of these numbers from 5 is about 2.65. So notice these three are all the 5, so their average distance is, their distance is 0. This one's 1 unit away, but the 1 is 4 units away, and the 10 is 5 units away from 5. So when we average all those distances, essentially we're coming up with 2.65. So we use this measure in other things in statistics, but again, right now what I'm going to tell you is this is a standard deviation of the full population. This is not standard deviation of the sample. That you will learn more about in statistics class. If you have any questions about this, please ask me during video conference, folks, and I hope you had a good time. I will talk to you soon. Bye.